turn the project in early.
Hey everybody, the project is coming up. Oh, that's the wrong screen. Let's go over to this screen already. Hey, the project is coming up, so we might have some people joining in here soon. Oh, there's computer audio's on. Probably restreaming the stream in the background. Let me look at that. Yep, looks like I'm restreaming the stream. Sorry, we probably got some reverb in there. So now the stream is not streaming in the background. Good thing I saw that, or this stream would have been crazy. Especially if we... Hey, what's up, Neeland? Outro, what advice do you have for these 2 seconds? Cool, let's talk about the project here for half a second. And sorry about the computer. Let me put the computer audio back on. That's my sound effect audio. Can I play sound effects on this screen? I don't have my sound effects. Let's just computer. 2 seconds, Neelan. Let me turn those off for now. What is going on with computer audio? Do you hear any extra? That's muted. That's so weird. Black Magic, Hoot is back. It's the randomness. I have too many things on here. Let's see. If you check out the beginning of the stream. Awesome. Let's do this. Let's talk about the executive summary. So the biggest thing, if you're on the executive summary, amazing work. With the executive summary, the biggest thing is knowing that, one, this is the biggest thing. Let's talk about this here real quick. Executive summary. 1, should cover your whole report. So when you think of an executive summary, it's literally a summary you would give to the executives that would cover your whole entire report. You're like, wait a minute, I have to summarize my whole report? Yes. That is the point of the executive summary. Like, here's how you do this. You lay out or give in detail what you will be investigating. Give your findings. Give your conclusion. Decisions. So, the whole point of an executive summary, I know this is going to sound crazy, but the whole point of an executive summary is so that someone doesn't have to read your report. Does that make sense, Neeland? Like, you can summarize the whole report. It's like a Cliff Notes version. And so if you're just the worst executive summaries, which I've done, I've grown my understanding of executive summaries over time. And unfortunately, and please don't use old projects. Please, you might have friends' old project, because I'll see things that just are echoes of like bad ideas, because I've definitely grown my understanding of executive summaries. And I'll say this, like, we had a meeting at the Haslam College of Business undergrad, and in the meeting, they went over exactly what they want in executive summaries and what you should do in the business world. And I sat there and took notes, and then we augmented Stat 201. And this happened about 2 years ago. And since then, Stat 201 has very much been a lot more business oriented. We've always been business oriented, but being in that meeting and being around everyone in the College of Business and them saying, this is how you write a good business report. This is what we want our students doing. And then I said, okay, we're going to have our Stat 1 students doing that. But I still have the echoes of things we've told people in the past haunting me. And, you know, the openings we used to get were not as quality. And unfortunately, we only have one project in the summer. That's like good or bad. But because of that, some people might get hit very hard on this executive summary. Do I get a lot of concern for the paper or more broad ideas? You can go into some, like I'll tell you, I'll do one of them right here. I'll go through one example of something, and I'll kind of clarify the difference between the report and the executive summary. So let me do something you won't do in the project. So here's a statistical test you won't do. This will be in Tuesday's lecture. So you're getting a peek into Tuesday's lectures. Hey, Brian. Hey. Yeah, we could do that. So when you have that, you pretty much just need to, because you're probably doing stuff like the extra cheese, the onions, and all that stuff. And the reason I used data like this is because it should be pretty easy to talk about this right here. If you look at this, we get a bar chart right here. You can make adjustments or however you want it to look. Don't feel like you can't adjust these things. You can make any adjustments you want to them. But when you look at this, how would you talk to your friend about your business? Just think about that. How would you talk to your friend about the business? You would say something to them like, you know, we had of the 200 pizzas ordered, 12% of them were pizzas ordered with onions. We could also say, we go here to the confidence intervals. We can make 95% confidence intervals. We could say the true proportion of onion pizzas that people order is contained in the interval 8.2% to 17.2%. Like, I'm 95% confident the true proportion of onion pizzas that people order is contained in the interval this to this. And this is kind of good right here, because what would this lead to decision-wise? Well, decision-wise, this will tell us how much like we need to order for onions. Like, we've got our low-end estimate of how much we need for onions a week, and we've got our high-end estimate of onions. If you think of this as 1 week of pizza sales right here, which I might have said in the report, but if this is like over a certain period of time, then this is a good estimate of what we might see in the future, because we're trying to estimate the true proportion of onion pizza sales. So if we want to go towards the high end, we'll make sure we have more than enough. So whatever 17% of our sales in pizzas would be, if we project out going forward, we can make an estimate saying we need to make sure we have enough to at least cover 17% of the pizzas being onions. We might, you know, that's a very high-end estimate, but what if someone calls and they're like, I want onions on my pizza, and we're like, we don't have onions. They'd be like, wait, it's on your menu. Why don't you have onions? Be like, too many people ordered it this week. I mean, I guess, you know, for mom and pop places, you might hear that. You might hear like, oh, we ran out of this topping. I mean, I've seen it. But then you feel a little bad. You're like, I really wanted that onion pizza, man. They make it really good. I just want an onion pizza right now. I like onions a lot, if you can't tell. So once again, you're thinking about the business decision with this. Don't look at this data as just like, you know, you just make a graphic and you're done. Like, what does this mean? Why would we want this information? What does this mean to us? Does that make sense, Neelan and Valerie? I was going to do here a 2-sample T. Like, when you go through, you'll go into more detail in the report. You'll give the graphics in the report. But in the executive summary, you would say something like, you know, projections. Like, if I were to summarize that, I would say, like, we noticed that 12% of our pizzas were onion sales, as opposed to this having this sales, this having this sales, this having this sales. We can use these numbers to help us make projections going forward on our ordering. And that would be a whole summary of each of the things without the graphics. I can summarize really each part with just like 1 or 2 sentences, and just think about like telling the reader like the important like cliff notes of it. Like, you want to reword it a little bit, but just be like, how can I get this information across quickly? Like, 12% of our pizzas in the business were onion pizzas. You might not, you know, you might say confidence intervals were made, which we could use. Like, you won't tell the confidence interval. You won't say, I am 95% confident, blah, 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 blah. You won't say that in the executive summary. You might mention them and say, confidence intervals were made, which can be used to estimate our, how many onion and such pizza, how many are the onions we'll need to order. Can we do the problem after radioactive? You got it. We can do that one. So about 5 to 8 sentences. Yeah, that's good estimate of length right there. I would say that'd be pretty good. It's strong sentences and you're good. I won't be too picky, and I think we'll have a grader for it. We will have a grader. You can do a test right here to see the pepperoni pizzas versus the non-pepperoni pizzas. And this is what we'll be doing on Tuesday. And it's pretty easy to tell if there's a difference between the pepperoni and non-pepperoni pizzas. I had you guys do it a different way by making 2 confidence intervals, and the confidence intervals did not overlap. There was a difference between the confidence intervals and their estimates for the true mean for the 2 groups. And this graphic right here clearly indicates to us that the pepperoni pizzas on average are getting 2.2 points higher. So we're testing here mean 1 versus mean 2. And the difference between the means, which is the difference right here, is this. And it's really awesome. Do you guys know what 2 divided by 0.2 is? The t ratio. 2 divided by 0.2 is this number here, and that's the t ratio, which is the standardized difference. And t's are like z's, and since the t is big, the p-value is small, and you can see it's way off the curve over here, which you can't even see the p-value. And you notice the interval here does not contain 0. So if any of that made any sense to you, you're kind of learning the next chapter we'll be doing, chapter 17. We'll do chapter 16 and then 17. And let's do Carly's question right here. Watch this, Carly. We're going to hop right in that question. Boom, we're in it. We got this question going. We got radioactive fallout. Radioactive fallout. Radioactive fallout. Radioactive. Where you at, radioactive? Radioactive. There we go. Radioactive fallout. So, and everything's coming through clear. For some reason, the computer was making noises, and that was weird to me. Radioactive fallout of atomic testing. There were 240 people in the region. 39 of them eventually died of cancer. Cancer's estimate that one would expect 24 people to die of cancer in a group that size, assuming the sample size is typical. So, one, they need to randomly select these people. Condition number 1, randomness. Random playing in the background. You bet playing. Hey, what's up, Alyssa? We got condition 1, randomness. Condition 2 is less than 10% of all people are selected because we want less than 10%. And condition 3 is success failure. Now, condition 3, nice job, Alyssa. Condition 3 right here relates to the 39. That's actually X, and X is the answer to, it's actually this right here. Excuse me, it's NP0. It's NP0 because right now we're using kind of the NP version of it. So it is met via the 26 because we'd have to have at least 10 according to the null. So this is success failure right here. Valerie, amazing job. Valerie, 50 points. You are totally right. Because it's categorical, it's success failure, and it's technically the 26 meets the condition. So 26 is more than 10, and then this is going to be NQ0 right there. So both of those are more than 10. So all the conditions are met. Now, what is the null and alternative? If you notice here, this 26 right here is P0. It's kind of like X0. Watch this, 26 divided by 240. And there you go. There's that 10.8333333333. So this is kind of what we would expect. And you see how it says one would expect? That makes it kind of true according to the null because the null is what we expect by random chance. It's the most likely thing. So it says, is this death rate unusually high? So we have a few options right here. Every null here has the what? They're trying to trick us because now we have 3 viable options. Every null has the equal sign. But if you read this as a sentence, it makes sense. This one right here reads, the alternative, which is what we look for evidence for, the alternative is the true proportion of people who die is greater than, nice job, Valerie, this number right here. The true proportion of people who die, because that's P, the true proportion is greater than P0. And P0 was found via 26 over 240. So that is the answer right there. Just determine the Z statistic. Cool. We can do some Z stat stuff. Let's do the Z stat. So nice job, Tyler, on those points there. For the Z statistic, we need Z equals P0 minus P minus P0 over P0 times Q0 over N square root. Have we identified any of this notation so far? Who can tell me any of the notation we have identified? So what of the notation have we identified? We've identified one thing. What have we identified in this problem so far? So take a look at this screen, and there's a few things. Can anyone figure out any of the notation I have for the equation? Can you tell me any of the notation? I need help with the notation. We need to figure out all this notation right here. If you can get the notation, you can usually get the problem. Try marking your notation. Usually we do it for first thing. Any of the notation. Wow, we're stumped. Yes, N equals 240. And remember, P hat equals X over N. So now if we can find X, we might be able to find P hat. Does anyone see X on here? Be careful, you might get tricked. There's 2 numbers that could be X. And just read around the 240 is my hint. What is X? X is the amount of successes in the sample size. X is the amount of successes out of the sample. So X has to be the amount of successes out of the sample. Be careful. And that's where, don't worry, that happens a lot. X is 39 because X is out of the 240 we saw 39. This is according to the null right here. So we use that to find P0. So it is 39. Yep. So that'll be 39 is because 39 out of the sample. So this right here is equal to like 17%, 16 point something. 39 divided by 240, 16.25. I could have figured that one in my head. There we go. And now we just need P0. P0 is weird in this one because the way they kind of give it to you. Yep, great job, Alyssa. 50 points, Alyssa, following along. it's 26 divided by 240 because that's what we would expect according to the null. It's also used right here. P naught is definitely this because it's the number they're using. This is P equals P naught. The general notation of it is P equals P naught. So this literally has to be P naught. Like, they're giving it away by showing that. They're like, that's P naught. And you're like, okay, that's P naught. And then knowing how they find it is important. Once again, they find it by 26 divided by 240. Or 26 divided by 240 also works. There we go. So that's how we have P naught right here. Important to know how they found it in the problem. We don't want PowerPoint. Go away, PowerPoint. I said go away. Okay. So this was 0.108333. Okay, cool. We're just do a little shorthand in here. I guess we could find Q naught. I'm gonna round this. Do not round your numbers. It's just I can't write that small. If I try to write small, it'll look really bad, and then no one will be able to read it. Do not round your numbers until the very end. This just makes it legible. Do not round. I need a big thing that says do not round. You just can't read Brian's small handwriting if he tries to write small. It'll look really bad. Okay. So once again, don't round. I'm going to solve this equation right here with the numbers that are actually on the screen. So there's that. I'm going to take 1 minus that and get Q naught. That's P naught times Q naught over N. And we get this. Then we square root it. We have now found this. This has now been found right here, which is really awesome. About 2%. Do not round. Do not round till the end. We'll do Jose's question next year. So if you notice, I did P naught times Q naught over N square root. That's the standard error. Yep, you got it. 10 a.m. tomorrow morning, I think we said 10 a.m. 10 a.m. So now we do 10 point this right here, which is the top number without rounding. And then bottom number, that's the difference. Standardized statistic says go about 2 point. There we go, 7. So that's the T statistic here. Oh, we can guess the p-value then. So there's the Z statistic. Do not round, round to 2 decimals. There's the Z. The p-value is going to be very, very close to. So close. It's my guess. And then this is definitely very. Let me show you how I get this. I don't want to go. I want to not show you. Let's show you, because obviously you need to see. Go to the David M. Lane. It has the most decimal places. On the David M. Lane, we are doing a right-tailed test. So here it is right there. I was close, but not close enough, maybe. We would find out if we checked it. But I'm also using my knowledge of the empirical rule when I do this. But does everyone understand? Please stop me if you don't. Do you understand why I'm doing this right here? Why are we graphing this direction? Why am I graphing to the right? Why am I not doing below? Why am I not doing between or outside? Why am I doing above it? Why did Brian graph above? What about this problem told me to graph to the right of it? To the right of the z-score. Why did I do that? Why did I do that? Why did I graph to the right? Who sees it? 50 points. Oh. Can I highlight it? I can't. It's a bummer. This right here. This right here is the greater than alternative. It graphs to the right. If we had done this one, we would graph to the left. If we did this one, we'd graph both sides. So when you have the greater than alternative, we graph to the right. When you have the less than alternative, we graph to the left. When you have the does not equals, you do the two-sided alternative. Does that make sense to everybody? I'm graphing to the right of the z-score because we have a greater than alternative. That is key. Graph to the right because we have the greater than alternative. If it was a less than alternative, we'd put in the z-score here, and we'd graph to the left of it. If it was a does not equals alternative, we'd put in the negative and positive version of it, and we'd graph the outside. So this is the outside right here, and I didn't put in the negative. Let me put in the negative, and there we go. Wait, really? Oh, it's because the decimals. Really, there's too many decimals, so I didn't like that. There we go. So this is the two-tailed, this is the greater than, and this is the less than. So, yep, graphing always depends on the sign. So make sure to graph the proper way depending on the sign, and you will get it. This p-value right here we found out was this. I want to see if I guessed it. Is this unusually high? It's going to use an alpha of 0.05. The p-value here is low. What are you guys going to do to the null? The p-value is low. What the null? Is the death rate unusually high? So then the p-value was low. We're going to reject the null and say there is evidence that it's unusual. So the p-value is high. The p-value is too high. There we go. P-value is low enough to conclude. Yep. Does this prove? No. Prove, just when you see prove in statistics, hey, what's up, Elizabeth and Jose? So when you see prove, and Olivia right there, and we'll do Jose's question next. When you see prove, that's just you don't prove things with statistics. Statistics doesn't prove it. You got it, Alyssa, right there. And we got it. Oh my gosh, what went wrong? My Pearson, I didn't say not today. Well, this has to be right. Let me look. Okay, that has to be right. Are the assumptions met? Yes. Is this met right here? Greater than 2 decimals. That is the 2 decimals. We wouldn't get both of these wrong. We'd get one of them wrong. P-values have to be right. Oh, it's this right here. Oh, I said... I said it. I need to slow down and read the question answers. So I was like, everything I did, all the steps. It's just the wording. Does this does this prove? No, it doesn't. Sorry, someone already submitted their quiz. No. Will the death rate? It should just say no. We can't prove causation. Statistics don't prove things. Statistics show associations. We can't prove it. They're associated. It is true that they're associated, but we can't prove it. So they tricked my Pearson. You put a no right here because you know I'd look for that no. The answer is no, but it would be no. Whether the death rate by cancer is unusually high or not, no. This just reads weird. Whether the death rate by cancer is unusually high or not, it is unusually high. The cause, it should say no. Even though the death rate by cancer was unusually high, the cause cannot be determined. Yeah. I know, my Pearson got a... It really should say no, whether or not... See, this one, the reason this question's wrong is because it's saying you got a high p-value. It's saying you didn't reject the null. This one is like, I did reject the null, but I can't say there's causation. So it might as well say, no, even though I rejected the null, I can't show causation. And this one says, no, I was unable to reject the null. So that's why that one's wrong on the bottom, because it's saying you didn't reject the null. Let's do Jose's question, and we'll say not today, my Pearson. Not today, my Pearson. Not today. You're not going to trick us again. Once in a day is enough. National Vital Statistics. National Vital Statistics. National Vital Statistics. Here we go. Okay, I need your guys' help with the notation. Brian is stumped on the notation, as per usual, and only his students can help him. I need your help to identify notation in the following problem. Is your choice to accept this or not? Good luck. Who's got some notation for us right here? We see in 1993, well, that's a number. We won't use that. A national vital statistics report indicated that 2.6% of all births produce twins. Is this rate of twin births the same among young mothers? It almost sounds like we're going to test that number there. It almost sounds like the 2.6 is the value we're going to test. We have here that 508 women were taken for testing, and they had 8 sets of twins, and I think that's it. Who's got a notation in the chat? Who's got a notation for us? Who has some sort of notation? P0, you are right. Nice job right there. P0, we got N. So P0 is equal to this right here. That is our hypothesized amount. We can even write the null now. We can write that the null is equal to this right here. Because remember, null is... So we got our null written. We've got our N. We got one more. What else do we have? Because then we can find another thing. Once we get this over here. So what else do we need? X is equal to 8. You got it. And now we can get p hat. So now let's get p hat. P hat is 8 over 508, which is like 1.4%, 1.57. So then we go here and we go to, there is p hat. And now we need to know the alternative. Is it the same among young mothers? So can anyone tell me what sign I'll put here? Now, if you remember how to write the alternative, all you do is you take what the null has and you change the sign. So if you remember from lecture, all we do is change the sign, and then we look at what the question asks. So what am I going to do? What's going to be my sign for the alternative? Any ideas for the sign? Any ideas? Who knows what that sign's going to be? Not equal. You're right. Julio. We got to do it here. Got to be like, Julio Bourbon comes in to save the day. Did I just like shatter everyone's ears? I don't know. That's awesome. So, I love it. I love it. So, what it is you have to see what they're asking. You have to see. Can we be playing? I don't know what's going on with my music. 2 seconds. I don't know what I did to the computer. I'll fix it. The same thing right here, the same is where you ask, is it the same or not the same? So the wording of the question indicates the sign. So this right here is linked to the word, where's Spacepen? Spacepen, you're up, Spacepen. To look at the previous question we did, which I don't think I copied, the previous question we did, if we look at it, hopefully we didn't lose that. Please don't change the question. Let's look at this question right here and right here. What indicates in this question the alternative is the following. We've got, is it unusually high? So that leads to the true proportion is greater than this. So the null always has the equal sign. And then, is it unusually high? Does that make sense? Yeah. And so you have to find a word in there that says, is this unusually high? Is it the same? Is it this? Is it that? Like, is this decreasing? Is this increasing? So you have to find the word that connects to what they're looking for evidence for. Is this unusually high? Is the true proportion greater than this? Is it the same? So then we ask, is it the same? Is it not the same? So good thing right there. Alyssa and everyone, great job. Please, I know there's, like I say, please ask questions. Like, you guys are doing great. Like, once you see it, you're like, oh, we just have to see. It says, are they the same? So the alternative would be not the same. So once you see it, it's like one of those things. Once you see it, you can't unsee it. You'll be like, oh, it just wants to know if they're the same or not the same. It didn't give a preference like the last one wanted to know if it was higher than what we expected. So once we have all of this right here, we just write our notation out. We've got all the notation written. So we're so close to solving this, and we haven't even looked at what my Pearson's asking us for. We now write in p hat minus p naught over p naught q naught over n square root. This is equal to the z-score right here, which we'll use to find our p-value in just a moment. So let's go ahead and put our notation in here. Wrong button. We're going to put in all of this notation. 508. P naught was equal to what? Do not round. Brian is rounding for... Someone's going to watch the video and be like, why'd you do that? I can write this one out. More numbers I get, the worse my handwriting gets. Good. And then p hat minus p naught. What was my p hat? And then minus 0.026. There we go. So p naught. And so now we have it right here. Let's go ahead and solve for the z statistic. P naught, Q naught. I always do my P naught, Q naught like this, and then I multiply them. So there's P naught times Q naught over N square root. Really? P naught, P naught, Q naught, P naught times Q naught over N square root. Okay, so now I have the following number. Everything I found right here is this. So now we're going to take the difference up top, and we're going to find it. This is a negative z-score. And then we're going to standardize that difference. So this is a z-score of negative 1.45. Who here thinks the p-value is going to be big or small? This is a z-score of negative 1.45. Who thinks the p-value is going to be big or small? Look at the z-score and think about where you would land. Always try to do like a quick drawing for yourself of it, of what you should get. Like, think of like a quick, really quick drawing right here. You landed right about here at 1.45 standard deviations away. And here's what your p-value is going to look like. This z-score right here is where... There's a weird noise outside. You landed here, but also we do the positive version of it because it's a does not equals alternative. So we're being able to do this quick drawing can help out. Does the p-value look very large? Let me say very large, kind of small, very small. What do you guys vote? Very large, kind of small, very small. I'm guessing it in my head right now. I'm going to put a guess of the p-value on here. I know what it has to be between. It has to be between... I don't want to say it because then I'll be giving away. It's going to be like... It's my guess. It's kind of small, but not small enough. It's not small enough for us to reject. So we're going to take that. It's kind of... So imagine this is like a pizza, a weirdly shaped pizza, and you only have about 13% of it. And my graphic might not look so perfect. I know this has to be between 10 and 20% with the numbers I know on the empirical rule. So we're doing the outside version here. That's not the z-score. That's the z-score. There we go. And I said about 13%. It's about 14%. But when you look at this graphic right here that we have, does it look like the following right here? Look at this graphic I drew out as an example, and then look at this graphic right here. So we can just put them side by side on the screen so you can see what I did as a kind of quick drawing, and I guessed at the percentage. I kind of made a guess. Now, don't worry if your guesses are wrong. It just doesn't hurt to take a guess. So does my graphic kind of look like this graphic? Yes, and look where I put my lines. I put my lines at a z-score of negative 1.45. That's where the bottom line is, and then the top line is at the positive version. Now, why did we pick this? Because of the two-sided alternative, we shade both sides. So because of this, we'll always click the outside to get the two tails. If it said greater than, we would pick the above, and we'd put in the p-value. I mean, the z-score, excuse me. So there's the above. Here's the below. And so we have the above and the below, which add up to 1. And then if we double the smaller one, we get the two-sided. So does that make sense on where these p-values are coming from? That's oftentimes where people get stuck, is you take your z-score, and then you put it in here to get your p-value. We won't use tables. We'll show you pictures, or we'll ask you theoretical stuff. But we now have the p-value right here. And I'm going to change the thing I wrote into the sheet just so no one looks at this and is like, wait a minute, that wasn't the answer. That was a guess. It's kind of close. It's tough to guess the middle. Let's check it out. Let's go here. Let's put in... Well, we basically solved the problem. So we were working the whole problem without working it. Here it is right here. Did it change the numbers? Oh, I think it did. I should have worked the whole problem before I changed it. Oh, no, it didn't. Are they met? Yep, they're met. We're trying to see if they're different. The z-score right here was negative that, I believe. Let's look at the z-score again. I wrote it down 2 decimals. As long as I didn't... Let me go to the applet. It rounds to 6. I'm going to get it wrong because of that. Darn, don't want to do that. The p-value right here was the 14 point this, which rounds up to that. What's your conclusion? So are we going to reject the null or fail to reject the null here? The p-value is high. The p-value is high. So what are we going to do here? The p-value is high. And it doesn't tell us an alpha, so we can assume 0.05, which means it's higher. The p-value is higher than alpha. Reject or fail to reject. Let it fly, Jose. You're right. 50 points, Jose, right there. Not today, my Pearson. Not today. If you say it, then it's not today. Gotta say, not today, my Pearson. Not today. Not tricking me again. What other ones do we have? We got some fun and easy ones. Like, there's these right here, which you can literally do this. Why am I doing this right now? Why am I just... I've got half the question right. Just like that. Half the question done. What do I know that I can just be like, done? On those parts of it. Like, whenever I see something like this, I'm like, okay, I know the answer to that. Because what? You should know it, like, boom. The null always has the equal sign. The null always has it. So you don't even need to look at it. You can just be like, well, it's the null. It has the equal sign. So we're good on that. When we do this right here, we need to see the way that they're asking the question. they want to keep their negatives below a certain amount. Since they want to keep their negatives below a certain amount, that means which of these alternatives? Option 1, 2, 3, or 4. They want to keep it below a certain amount. So they want to keep it below this 49%. So what do you guys think? Option 1, 2, 3, or 4? Which of those do you think we should do because we want to do below a certain amount that they're looking at? Like the true proportion is below this amount. Which of those sounds? Option 1, 2, 3, or 4. I need you guys' help on this. 2, boom. And then is a four-sided spinner fair? Well, if it's fair, it would be equal to this. If it's not fair, it would be what? If it's fair, it would be equal to this for a particular section. If it's not fair, option 1, 2, 3, or 4. Which option would it be here? Because it's either going to be fair or not fair. And what's it mean for something to be not fair? It would either spin it too much or too little. It would probably spin it not that amount. Yep, option 2 again. Only 17% of people who try to stop using drugs succeed. These people say that they can help people. So if the true proportion, if they're helping people succeed at this, the true proportion would be what? Nice job, Nikki. If they're helping people succeed, it would be what here? The first, second, third, or fourth option. If they're helping people succeed at quitting drugs, what would they be doing? Would they be increasing the proportion who succeed at quitting, decreasing it, making it less than this? Would they keep it the same, which is the null? Or would they change it? This kind of mean change, like it's not the same. If they're helping people succeed in quitting drugs, I would say it is option. I thought I had music on the screen. It'll be this one. So when you read this, this is the true proportion who quit at drugs using this program is greater than 17%, and they want to help people succeed at quitting drugs. Does that make sense? They're saying we want to help people succeed at quitting drugs, so we want to show there's a higher proportion of people who quit drugs using our program. Regularly, we would expect 17%. Like imagine this. If you don't do anything, 17% of people quit using drugs, but who try. But if they use the program, you want to show that a higher proportion of them quit using drugs if they're doing your program. So it's like if you do this program, the proportion of people who quit drugs is higher. So they're trying to show evidence that people are more likely to quit drugs if they use this program. So it'll be increased. Elizabeth, 50 points. I don't think I've given you 50 points yet. And Nikki, 50 points for hanging in here. Don't worry. Just take a shot and then I'll explain it. They're wanting to see an increase in the true proportion. It's what they're investigating for. They're trying to show evidence. Think about that. They're trying to show evidence that their program works. Does that make sense when I say it that way? Is there evidence that our program has a higher proportion of people quitting drugs? Because the alternative is the evidence-based one. You would assume without the program, like, if the program has no impact, that 17% would quit because 17% of people who try to quit drugs succeed. So if you don't do anything, 17% would probably quit anyways. But if the program is successful, the proportion of people who quit drugs, which that's what P stands for right here, would be greater than 17%. And do we have evidence for this alternative? Does the data show evidence? So that's a really good one. Just reading these and questioning these. P-value's probability of our results or results from our stream happening by random chance variation given that the null is true. And that's what this says right here. It says, this is the probability of sampling variation producing a result like our results. This is the probability of our result. There's literally our result. Here's the probability of our result. And then if there really is no change, is the null being true. So when it says, if there's no change in public opinion, that literally means that the null is true. There's my mind. So it's saying, what's the probability of what we observed, 72%, or a result just as extreme, given, here's the probability of it, which is the p-value, given the null is true. Like if there is no change, what was the probability of observing this? Good, decent way of saying p-value. Boom, easy answer. When you get something like this, if this was on the test, I'd be like, yes, done. I know the answer to that one. An organization monitors 2,000 numbers are often used as a baseline to assess changes in 2,000. Oh, there we go. It's saying right here that the 2,000 numbers will be used as a baseline. And so we're going to use this as the null value. You can see it right here. If you were to see this in a question, you can easily identify this as P naught. Now, why is it not mu naught? It's because it's proportions. So since we have P here, this is P naught. If this was mu, this would be mu naught. And this is the hypothesized amount, which they're using as a baseline right there. We have a 2004 survey with this many respondents. That becomes N. And we see that the figure has slipped to 36%. Now this is going to be p hat. We have n, which is the sample size, and we have p hat, which is the proportion from the sample. We don't have x, but we could find x. X would be found the following way, by going to 884 and multiplying it by this, and we've now found x. It's weird that it turns out this way. If you put that into your calculator, round it up with one prop z-test. So you can do this with one prop z-test. Of course, officials would be concerned if student attendance were declining. Do these figures give evidence of a change in student attendance? I need help. Which alternative? There it is right there. Which alternative with that in it? So we've identified part of the question that's going to help us figure it out. Is it alternative 1, 2, 3, or 4? And I've highlighted the key words. They're looking for evidence of a change. Is there evidence that it changed? That's the key word we're looking for right there. That when we see that, we're like, ah, you're trying to tell me something. You're trying to tell me to use a certain alternative. You're trying to be like, hey, that's... I should have told Julio, if you're still here, check out some of the new coding videos. I've got how to install R and some really basic stuff. Throw some likes on them if you want. You don't have to. But the channel made almost 50 cents on Friday. And I really want... I wonder if I can still send announcements to you guys after the class is over. I'd love it for the first $100 we make to somehow give that away to students and, like, make it, like... I mean, I know, like, we talk about these things, like, with scholarships. We talk about, you know, like, would students actually want, like, we're like, hey, you got a $200 scholarship. Would a student be like, $200? But I mean, seriously, if someone's like, here's $100 scholarship, you know, for like food, books, or anything like that, most people be like, hey, $100. You know, we wouldn't want a family to be like, ugh. I mean, like, I don't know who would look at $100 and be like, I don't know. But, you know, you got to start small. And so if we do our first thing by giving away a scholarship, I'd really like that. And I just want people to know that is what the money is going towards. So I would just hate for someone to be like, he puts ads on his videos. It's like, well, I don't put them on lecture stuff. Nice job, Nikki, right there. I don't know. We'll have to figure out a fun way to do it or something. Or like, I don't know. So, but yeah, if they would want it, and be careful. Here's the thing though. This is where they trick you with this question, is don't look at this number, because even though the number did go down, it slipped. They're looking for evidence of a change. And they changed this question a while ago to specifically make it clear, because it was like they've made it very clear. It used to not be as clear. And then they updated their question. This is plausible that they randomly took the students, i.e. independent. It is also plausible that this is less than 10% of all the students. And success failure is literally met, because to check the success failure, we do NP0, which is going to be 8846 times this right here. That's NP0. And then we do NQ0, which is N. Here is N times Q0. And make sure you're using P0 and Q0. And then we get that, and that is Q0. Both of those are greater than 10, so that is met. These are plausible because you have to make assumptions, and you have to assume these are random. You have to assume this is less than 10% of all students. So for the Z statistic, notation. Time for notation. Let's do that Z statistic. You got it. Well, let's do that 1981 next. You got it. Is that Tyler right there? You got it, Tyler. 1980s question coming right next. Going back to the 80s. The 80s are awesome. So for this right here, we have to do our classic equation of R observed, which is P hat minus P0 over P0 Q0 over N square root. And then we do the Z. And let's go right here. Here's our N. Here's our P hat. And here's our P0. So we got all this right here. Let's go ahead and put it in. Oh, no. Can't erase that minus sign. And so Tyler, while I'm doing this one, I want you to identify the notation in your problem. So if you're looking at the problem right now, be looking at the notation on it, and we can do it. So we will do that one next, and you're going to help us out with the notation. So we need to now do P0 on the bottom right here times Q0 over N. And then on top, it's P hat minus P0. And I will say this, I used to make more mistakes on these problems. I'd do them too quickly till I started to be like, write down your notation first. Like, identify in the problem all the notation. Now I'm going to make a mistake. I've jinxed myself. So when I'd be like, okay, write down all your notation for each problem. And it's how I suggest people do the tests. Like, whenever you get a test question, identify the notation first. So I should make it a practice of always writing my notation first. Like, I should be like, wait, We got to write down that notation because if you make a mistake, everything goes bonkers. P naught times Q naught over N square root. We have now found the standard error. The t-score, the z-score is going to be about negative 1.89 or something. So we go 0.36 minus 0.37 divided by that number, and we get 1.948, negative 1.948. You know what's really interesting about this? Does anyone in the chat, you got it, well, we'll do both those next, you got it. So does anyone notice what this z-score is very, very close to? What is this z-score very, very close to right here? What is that z-score very, very close to? I'm going to draw something out while we talk about this. This z-score is very, very close to what? Try to figure out what that z-score is. I think someone just said in the chat. You got it. Oh, Jose, you get another 50. That's what I'm thinking even more. So Jose knows it's. I was looking at that. I was expecting 2, but Jose, you're even more correct because that's what my mind said, and I was thinking people might say 2. But great job. Now, why am I drawing both sides on this? Because we have to do negative of it. Well, that was what it was, and then we have to do the positive because we have the does not equals alternative. Since there's a does not equals alternative, we have to graph both sides of it. So Jose, the 1.96 is for a 95% confidence interval. So Jose, I'm offering you 200 points right here. I want you to guess what this p-value is. I want you to watch my hands real quick. You ready? It's like if we had 95% in my hands here and 5% outside and we did this a little bit. What do you guess the p-value to be, Jose? What do you guess the p-value to be? Do you have any guess? Because thinking 1.96 would be, you should know it's a 95% confidence interval. So what do you guess? What do you think this p-value might be? And this is how I guess p-values. People are like, how do you do that? And I'm like, well, I know this number, so I guess because of it. It's only a little bit different. It's only a little bit different. Watch, who is it? It was Zulan who got even closer. Well, it's only gonna be a tiny bit different. Remember, you're gonna estimate these areas here, how much the total is, not this inner portion. I think you might have been saying this is 93, but this will be even. It'll be. You're kind of right. You're going in the right direction. Yes. So if you guessed that, then this would be this. So does that make sense? You're saying the inner part is 94.8%. So then the outer part would be that. That's a decent guess. I'm going to change it, and I'm going to go to this. Let's see who's right. Watch, you're going to be right. You're going to win. I've trained you guys too well. That's not the z-score. There we go. Who's right? Jose, you were right. Look at this. You guys get it better than me now. You know my tricks. I should never teach you my tricks on how I guess z-scores. Or p-values. I should never... You probably... Jose, we're going to put in your answer here. As though we did not fill it out. So we put in the z-statistic right here. To 2 decimals. And since it even rounds, I bet you're going to be more right. So it's 2 decimals there. This is to 3 decimals. So Jose gets to that. It does round down to 1. State your conclusion with this. Well, we're going to reject. Here's where people get tricked on this one. Why am I rejecting the null? Someone's got to say it in the chat. Someone's got to help people out who are watching this. Like, wait, this is not below 0.05. That's above 0.05. Why am I rejecting the null? It's when the p-value is lower than what we reject the null. And they're playing a game right here. They're playing the bad statistics game. There's my script button. I haven't done so long. I didn't incorporate that one enough. What bad game are they playing? It's when do we reject the null? When the p-value is lower than alpha. So here's what you do. You look at your p-value. Yep, but be careful. They've changed it right here. Do you see that? Alpha is usually assumed to be 0.05. So if you don't see alpha anywhere in the problem, you assume 0.05. But since they've changed the alpha, is this p-value here lower than alpha? Does that make sense? They're playing a game because they're like, here's your alpha. And then you look at the p-value and you say, that's lower than alpha. Does that make sense? When the p-value is lower than alpha, reject the null. My p-value is lower than alpha, I reject the null. There is evidence that it has changed. So the key thing here is that we're seeing if there is evidence for the alternative anytime you reject the null, there is evidence. If you do not reject the null, there is not evidence. So you can only put these two together in these combinations on my Pearson. I do not reject the null, there is not evidence, or I do reject the null, there is evidence. So only one of those combinations will work. And then we were looking for has changed, because that goes along with this right here. Has changed is what we were looking for. Remember, this was our sign. Due to this, what they were investigating, we chose this sign for the alternative. And then when we get down here to this part, we select that. Is this a meaningful difference? It's pretty small. It's like 1%. Yeah. So I'll expand on this just a little bit right here. What you can have, and we'll talk about this more next class. Like, we'll go into greater detail. Imagine you and your friend run cross country. And over the course of your career, there's evidence that you're better than your friend. That would mean that there's a statistically significant difference between your times and their times. So someone might say, well, how much better are you? And you could be like, well, I run races a half a second faster than them on average. Does that sound like a big difference right there? And you'd be like, well, it's not by random chance. We ran 500 races over the course of our career. And when you look at the differences, there was a p-value of 0.042. So the difference we observed of just half a second was statistically significant between the two of us. You'd be like, well, it's half a second for a 5K. And you'd be like, probably due to your large sample, you were able to find a difference that although it's statistically significant, it's not really practically significant. And I'll do more examples in class. Another classic example I do is the following. Let's say there was a 1-hour seminar that is held nationally, and your salary will go up, and they have evidence that the whole first year of your salary will be higher if you go to this 1-hour seminar. I mean, what would you want to know? I say there's evidence that the first year of your salary will be higher if you attend this 1-hour seminar. I go, well, how much will it go up? And I say, well, we've collected data from tens of thousands of students, and we see that the first year of your salary will be $1 more on average. It's statistically significant. We have good evidence to say the first year of your salary for people who go to our seminar is $1 higher. You'd be like, okay, wait a minute. You're saying the difference you observe is not likely by random chance, but it's only $1, so I don't really care about it. And that means it's not really practically significant to you. So the practical significance is the literal do I care about it, which is subjective. The statistical significance is just the p-value. Not today, my Pearson. Not today. You know what? We even rounded the number. Thank you, Jose. Remember, Jose guessed that number. It accepts both of these. I thought it would. I was going to change that one if it didn't. But, Jose, you guessed that. So great job, Jose, right there. Yes, we got Tyler's question right here. Is it we're doing the 1980s? Let's do Tyler's question. An amazing job, Jose. You're guessing p-values now. You know what's going on when you can guess those p-values. It's fun. Okay, here we go. You might have it, Tyler. I think, is this the one you want to do right now, Tyler? I think so. Do you want to do the 350 first, or do you want to do this one? The 1980s or the 350? You call it, Tyler. It's your call. You got control of the board right now. 1980s or the 350 one? We're on the 1980s one. Oh, the same question? Oh, they are. Yours just got different numbers. Okay, in 1980s, it was generally believed that abnormalities would be 8%. So what is 8%? And you might have the notation marked. What is 8% in notation? You're kind of close. Yours is 7%. Yours is 7%, but be very careful. 7% is not P. 7% is what? 7% won't be P. Let me start marking my notation right here. You could mark it as P and be kind of right, but it's not technically. Like, you could still probably get it right and have the notation a little bit off. It's not technically P, though. I mean, it kind of... Statisticians were like, well, don't we assume it's P? I'm like, well, yes, according to the null. So the notation for this problem, highlighter, where are you at? Go. Let's mark the notation. Do we have it? This is n. This is x, which makes x over n equals p hat equal to... There we go. We now have p hat. And then this right here is p naught. They want to see, is there strong evidence that the risk has increased So when I see that the risk has increased, this is going to tell me, whoa. How did that change? Oh, it's the second pen. Greater than. So we know a lot of information from that. If you can't tell, that's a greater than right here. This is the greater than sign. My greater than signs just look horrible. So that's the greater than sign. And let's go right here, start writing our null and alternative. The null and alternative will be the true proportion because we're testing proportions. Null has the equal sign. This has the greater than according to the evidence they're looking for. And then we put the null value right here of 0.08. If you practice writing these by not looking at what my Pearson gives you and just giving it a shot right here of writing these out. So always give that a shot, just writing those out right here. And let's hop back in here. We can see that the null and alternative equals 2 and greater than. Got it. We have a random sample. We want them to be independent. We want them to be less than, and we want there to be more than 10 successes and failures. Now, this right here, the random and independent, they're basically the same thing. There's the randomness assumption and the independence assumption and the randomness condition. I just call them the same thing. Sorry if that confuses anybody, but if it's independent, it's pretty much random. And a lot of questions will allude to that. My Pearson just likes to change up the wording. Now, here's the hard part of this question. They hop right here to the p-value. Now, someone needs to tell me, what do I need to solve for my p-value? What do I need for my p-value? This would be a decent test question. I don't think it's on the test, but I mean, you should know it. It's like knowledge you need for the test. What do I need to get my p-value? I need this to get a p-value. What will I be solving for to get my p-value? I'll have to solve for this and then graph it. What will I solve for to get my p-value? This one's tough because it jumps right to the p-value. Yep. No, don't worry. This is where people usually get lost on this one because it's jumping a step. You have to do something to get the p-value, and it doesn't have you do it. It doesn't ask for it. You have to find it. And I kind of like this question because of that, because you have to be like, okay, what do I need? I need this to get the p-value. What do you need? I'll start writing it out while people are thinking it over. It's a very quick thing you can put in the chat. You can put in the chat. Who knows what we would need to get a p-value? Kind of here. I'll talk about it in 2 seconds. Neil, let's hang around. I will explain. Oh, I just gave away the answer. I was going to write that last, but my brain wrote it first because I think I was thinking about it. That's what we need right there. We need the z-score. So you need the z-score for the p-value. And we already have all of our notation marked. So we have to go ahead and get the z-score for this right here, which is going to be p hat, which is 0.0... Sample size. What's your sample size? There we go. There is the z-score. Let's figure out what that z-score is. That z-score is the following. There we go. Well, I do the bottom first. P0 times Q0 over N square root. There's the standard error. Boop, standard error, that's that. We copy it. There's the z-score, and that's a very large z-score. Let's go, Brian. Coming to... Oh, thank you, Keaton. Here to help. You got it, Keaton. You got it. Good to see you, Keaton. Everyone's doing great. That's the p-value. We don't need the p-value. I mean, we need it, but we have to go here to the... Which sign did we get? We got the greater than. The p-value is going to be something like... Before we click it, we got to guess it. P-value is going to be 0.028. Ah, got the last number wrong. 0.022. I should have just said 0.002. And hopefully I said that second zero because I knew it would be close to 0.015 because that's very close to this right here. So because of that, I took a guess related to that. So I knew, oh, I said 0.015, didn't I? I'm forgetting to say the extra zero. Well, it's half of 0.3%, which is 0.003. Cool. We took a pretty good guess at it. I wonder if we would have gotten it right, but we don't need to see. We can just go right here. 3 decimals. Wonder if I 0.03 would have gotten it right. 0.003. You keep saying the extra decimal. Is the p-value here low, or what is it? What does the p-value mean? The p-value is the probability of observing this much or more in a random sample of this, if this is actually true. This is given the null is true right here, which is a very important thing. The probability of our results or results from our stream happening by random chance variation, given the null is true. There's the definition of a p-value. What conclusion do we have? The p-value is low. Something, something. The p-value is what? You guys got to help me out on this one. This one's easy. We got this. The p-value is low. Blah, 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 blah. And that would mean what? Reject the null. And if we reject the null, there is evidence. There's only two possible answers right here. We can say we fail to reject, there's not evidence. We reject, there is evidence. These are the only two possible answers. And how do you know to reject or not reject? The p-value is low. Reject the null. I have evidence to the alternative. So remember, these are the only two possible answers. It does not make sense to say I reject the null. There's not evidence. If there was evidence, you would reject the null. Evidence for alternative. Does this mean that they cause... I think it's going to be the unknown. Yeah, we can't say yes or no. We're going to say it's unknown. And what do we say to my Pearson? We say... Not today. Not today, my Pearson. Never today. That's what we say. Never today. Let's see if we would have gotten it with our guess. We would have gotten it with our guess. So I guessed 0.0028. You're welcome, Tyler. Great work, Tyler. And then Neelan wants to know about the outros. So we would have gotten it with our guess. We guessed 0.0028, and we would have gotten it. You got it. We'll do startup next. You got it, Jose. So let's go right here. Let's talk about that outro. So when it comes to the outro, the biggest thing about the outro... Don't do this. Let's do this outro right here. With the outro, do not just go through results in your report. This is how you lose points right here. I think we did, Keaton. Did we? Rewind the tape. Check it out, Keaton. I think we did. And I can do it again if you want. We'll keep going through questions. Here we can... Yeah. Wait. We can check it real quick if we did it. Pretty certain we did it. Is it this one? Yep. I think it was earlier on in the video. I think it was one of our first ones. And so Keaton, here is the notation. I think it was the very first one. Yeah, go to the very start of the video. And I think it was like the very first one. And if you're stuck, we'll do it. Yep. Thank you guys. You guys are awesome. I need to this weekend make my Stat Nation. I might make the emoji. I'm going to try to look up how to make emojis on YouTube. If you guys have any suggestions, but I like the Stat Nation stuff. So Stat Nation, help each other out. Keaton and Neelan, 50 points right there. Stat Nation. I thought about, like, what if I changed the YouTube channel to Stat Nation? Instead of it being Stat20 UTK, we became Stat Nation. If we could get, like, if we could, like, grow the channel, I'd totally do that. We'd just be called Stat Nation. So I like the name of it. I know it's like, I don't know. Part of me just wants to do it. I like it too. I like it. You guys came up with it. I know it's Stat Nation, and like, it's like, need to make a channel. Be like, do like a hair thing. Be like, what's up, Stat Nation? I don't know. The hair is getting crazy. I don't know. I'm like, do I just keep growing it or what do I do? Because this is getting out of control. Okay. I was afraid I was gonna like hit the microphone on my head. Okay. With the outro. Brian's going to get back on topic here. Don't just go through the results of your report. I want you to think about a Marvel movie. You know, when you go in to watch a Marvel movie, at the very end of the Marvel movie is like a teaser for the next movie. At the very end of the Marvel movie is like a, you know, like Loki appears and he like grabs the Tesseract or something like that. And he's like, oh, this is going to be interesting. And you're like, what's going to happen next? So when you think about an outro, it's almost like you're going to put like a mini movie at the end of your report. And I'm not saying do a bunch of new results. I'm thinking like, maybe I emailed Neelan about this. I'm trying to think who I emailed about it. But I want you to think about this right now. Okay, I think this is the best way I can describe it. Is I'm trying to show you the importance of statistics by saying to you, we need to do more. We can always do more. And I really mean this. What jobs like is they like creativity, ingenuity. They like people who are trying to progress what they're doing, who are never satisfied with like, well, let's just do it the same way. They want people who want to do it better. And it's tough because, it's the marketplace. It's like, okay, well, how are we going to beat this idea? How are we going to do better this time? So we're trying to instill that in you now by saying, we want you to take this report seriously. We want you to be like, okay, if I were to go forward with this and put out more reports, what would I do? I sneeze, never sneezing. So you should come up with new ideas. Now, just take a moment, think about this. I'm going to help you out this. If you've looked at the data, what could we have collected on that we didn't collect on for our pizza place? And I'll tell you what, this variable right here has a lot of variation in it, in and of itself. What could we have collected on for all these pizzas? And even the way this was organized, there's a lot of other variables I could have created for this. Because I just created this data. It's not real data. Sorry. I like real data, but sometimes you got to make fake data to make a project work. You got to, create data. This variable right here has a lot of variation in it. Could you think of any other variables that a pizza place could collect on? Especially if it comes down to this variable. What explains this variable? Let me do Jose's question. Oh, no one knows. 100-point question. Who knows 100-point question? What would explain time till delivery? Are there any variables that go into that variation? If we use this as a y. Now here's a big hint also. Sorry if someone's done this already. Don't use this as a y variable. The score right here is the actual score of the pizza. This is how long it took the pizza to be delivered in minutes. So does that make sense right there, Neeland? Hopefully that doesn't totally change your analysis. But this is how much sauce the pizza had on it. This is the score the pizza got from the customer. This is the time it took to deliver the pizza. So this is the 1 to 10 score the pizza got, and then this right here. And then the time till delivery is how long it took the pizza to be delivered. I would not use this as a y variable because then you could. Yeah, exactly. Oh, and then, yeah. Okay, wait. Oh, you're right. I didn't read what Neelan, sorry. Yeah, I did create that. You would think it would, but when you analyze it, it creates this graphic right here. Yeah, exactly. No, you can use it because it's interesting. This is the cool thing about statistics. It's interesting that it has no association. And I love it because it looks perfectly random. I created it via randomness. So you are actually seeing do I have the code on here? I don't think I have the code I used to create it, but I literally created random numbers to do this. And so this is purely random. And then one of these variables, I created a relationship on purpose within, so that way we would have something this was also manufactured. So, did I create it on this computer? Maybe I did. If I did, I can show it. I think I created it on the other one. Test file? No. Yeah, it's on the other computer. So I created the data to have this structure. I purposely made it so that it would have a really good relationship. That way, one of them does and one of them doesn't. I mean, this is ridiculously significant. And so, but think about this. What do you learn from this, Neelan? What do you learn from this graphic right here? There's something about the what that is really helping our pizzas, which is something you should find through the project. Yeah, mentioning there's this clear trend in the data right here, which lets us know what about our pizzas. Yeah, the amount of sauce is highly associated with there's a linear trend, the more sauce a pizza has on it. You know what I could have done is I could have made if I was really wanting to be mean, I'd put a non-linear trend where it dips off here at the end. Because someone could say, well, let's just dump sauce on our pizza. And you'd be like, well, we don't know the trend continues past this point. And I always just assumed that the sauce was ounces. Yeah, it's ounces. Yep. I literally Googled how many ounces. I like pizza with a lot of sauce on it. So I purposely thought about myself and I was like, man, I like it when it's got some good sauce. When you can taste the sauce, you bite in, you taste the cheese, you got the dough, and then you kind of finish with the sauce. And it looks pretty consistent. This is a very good regression. Yes, there's a little bit of heteroscedasticity here, but actually that is due to random chance because I created the data random from what would be a good regression. So this is meant to actually be a good regression. There's really not really any extreme outliers. You could try to identify like a point like this. If we hover over it, it should show up. So that's about one of our most extreme outliers right here. I'll be showing a lot more of this on Monday, like how to do these types of things I'm doing where you can identify a point. Like that's one of the most extreme. There's also maybe an extreme point down here. So we could hover over this. We could go here. And this pizza got a score that was, much lower than we would have expected. So if I was, think about this, we might even try to look up this pizza right here or this customer, like the history of this customer's reviews. So I'm mentioning stuff right now. We haven't analyzed the variation between the customers. So we don't even know maybe certain customers like pizzas a certain way. Imagine this. Imagine if every time you had a pizza from Domino's had you fill out a short survey about how much you like the pizza. Like all you did was rank the pizza like 1 to 10. And so then Domino's would look at what you ordered, and then Domino's would make suggestions to you on their sites based on like if you put like extra cheese or if you put this or that. And then Domino's, and it could even do like what we call market basket analysis. Oh, they could do that. Why is Domino's not doing that? Domino's could literally do this thing we call market basket analysis to look at the pizzas you've ordered in the past to make suggestions to you like, hey, you tried the Buffalo Ranch hot sauce pizza. You might like our jalapeno steak pizza. Which, I mean, think about that. Who would like a Buffalo Ranch chicken pizza? And then you might like the jalapeno barbecue steak pizza. It's like a spicier pizza, but with steak. And so it's almost like you might be like, ooh, that does sound good. I do like spicy stuff. And we do that via a thing in statistics called market basket analysis, that knowing people like this item, then the people who also like this item are more likely to like this item. It's probability in statistics right there. So we call that market basket analysis, and it's just trends in the data. People who ordered this item would be more likely to order this item. Yes, exactly, Neelan. You're on track. That's it. Your ideal outro will talk about ideas we have not done yet. And I'm literally writing my own outro right now by talking about I want to include some market basket analysis. So I would say something like we would really need in here like customer. So I would really want to know like customer data. So if I were to go back to them, I'd say like you need to identify like the customer number. Like what customer were these people? Does that make sense? So it's yeah, like identifying new things we could do, new ideas. Yeah. For the decision tree question, are we supposed to leave the points in black and white? You can change them to color. I like them in color. It's nice. I won't take off if they're in black and white, but I'd probably put them to color. It doesn't say do it, but I would. I mean, it's nice. I can't take off points if you don't put them in color. I can't be like, you didn't press the color button. I didn't tell you to, so I can't take off points. Great job. Elizabeth and Neeland, how's the project going? Not too bad. Really tough. Impossible. Too easy. What's the thoughts on the project? I think I'm going to go to the next question. Almost done. Awesome. How long do you think it's taken you? A startup company. Jose's question. We're doing Jose's question now. A startup company. It does take a little bit of time to do the project. I estimate, 2 to 5 hours. So are you at like hour number 3? And it's not grueling work. Maybe 4 hours. Yeah. And it's, so it's about halfway through. Yeah. And hopefully with all the videos and stuff, it's like, oh, you put the data in, not too bad, and it shouldn't be too grueling, but obviously don't wait till like Tuesday night at 10 p.m. to get it done. But it's been interesting. Oh, that's so cool. I like that. It's like, yeah, I've never done anything like this. Yeah. And I really like that, people hopefully can use these skills in another class to like be like, I can do some data analysis, like to actually have the abilities to just kind of put it in. Did you post a walkthrough video on it yet? I'll do that tomorrow morning, 10 a.m. tomorrow morning. I'll be online. We'll be working through the project. I'll kind of do questions similar to it, even though I've kind of done some today. Check out today's video where I've worked through a little bit here and there, and I will answer questions related to the project for those who have already gotten a head start. But tomorrow morning is when I suggest like sitting down and being like, tomorrow I'm dedicating to the project. I'm moving the assignment due tomorrow night due to Tuesday night. Because we're going to cover it in class on Tuesday. We'll go through the homeworks all on Tuesday. Tuesday's a big day, I know. Wednesday's a bit easier. It's mini term. That's all I can say is it's mini term. Every day is 5 days. So you're welcome. Yeah, I'll be moving that assignment due tomorrow night due to Tuesday night. And then there'll be 2 assignments due Tuesday night. So don't take that lightly, along with the project due Tuesday night. So that's why Do the project tomorrow. Do the project tomorrow. Like, I can't state that enough. Get the extra credit. Do the project tomorrow. I'm sorry if someone's not have time to do it tomorrow. It's mini term. How are you guys feeling about grades and stuff? Are you guys feeling good? There's a lot of great grades. A lot of people are doing extremely well in the class. Do you feel like you're learning? Do you feel like it's a busy week? It's mini term. That's all I can say. Review of the class. Brian just keeps saying it's mini term as though that excuses him giving us so many assignments. I'm sorry, but it's mini term. Okay. It's 3 weeks. It's a whole semester in 3 weeks. So we've had Stat 201 have 2 assignments due on one night in the regular semester. And I've found that that's a very bad idea. A startup company is about to market a new computer printer. It decides to gamble by running commercials during a championship game. Focus, exactly. If you stay focused, it's like, boom. A lot of people say they love mini term because it's like you stay focused for 3 weeks, you get the A, and you're done. That's what we do. The company hopes that name recognition, yada, yada, yada. The company's goal is that boom. Okay, wait. There's 2 things. This and this. Okay, this is what they want to see. Can anyone tell me I've marked 2 things right here? The first thing is what they want evidence of. The second thing is what they want, like, they're testing against. Does anyone know what either of those 2 things will be? And I'll mark the remaining notation. So, yep. Good job, Jose. Why do I have those 2 pens? I don't like that one. So, this is X, this is N, this is P naught, this is greater than. So we have all of this right here. So now that we've identified all of this, we can basically write it out because we can write out our null hypothesis. Our null hypothesis is that the true proportion is equal, the null always has the equal sign, to P naught. P naught is going to be 39%. We can write out our alternative that the true proportion is greater than this. We can solve for our z-score. We can solve for our z-score, which is equal to, not that yet. P hat, I don't have P hat. X over n equals P hat. P hat is equal to, is that about 40%? A little bit more than 40%, 42%? 42.6. Always try to guess it. It's more fun if you guess it. I think that was 42.7% when we round it. No. There we go. Okay, so now that we know, we can solve P hat. Let me write it out just so everyone can see what the equation is. P hat minus P naught over P naught Q naught over n square root. There we go right there. Let's take these numbers. Let's drop them in. And we have P hat here. P hat is our sample proportion. Brian's small, horrible handwriting right here. And then we do P naught. P naught is this right here. Then we do P naught, Q naught. Guys, I'm stuck. I don't know Q naught. I'm just going to take a break. I'm going to read some Attack on Titan. I'm going to read some Attack on Titan until someone tells me what Q naught is. Whoa, what's this? I was like, oh, this is like one of those safety devices. Whoa. Is that what that is? Bought stuff Amazon. It's got one of these. Whoa. Didn't even know that was in the book. What's Amazon doing putting those in here? They probably bought it from someone else. What's Q naught? Oh, you guys got it. Well, let's do it. Q naught right here. We got Q naught. You guys are following along. Excellent work. There's Q naught. Literally opened it right to that page, I guess because it was in there. I need to read my Attack on Titan books. I need to start reading them. It's like every night. You know what, I might do that? Like every night I should read one Attack on Titan book. Because like I might just like sell them off with moving. Because I'm like, I don't know. Moving. Fun stuff. Let's solve. I bought them. Should read them. Why am I solving the top of the equation first? P naught times Q naught over n square root. There's the bottom of the equation. That is that right there. Just so you know, this is this or this. Copy it. Minus this. Divided, and we got it. There is the z-score. So now that we have the z-score, we're going to go down to here, and we're going to do a quick drawing. With our z-score, we are testing the greater than alternative, which means I will shade to the right. So we're going to go right here. 500 points, first best guess of a p-value. You only get 200, though, if you don't beat my guess. I will not cheat and change my guess according to your guesses. Who has a guess of the p-value right here? This is where we landed. 200 points for best guess, 500 if you beat Brian. Anyone got a guess of the p-value? We're going to graph it. But who has a guess of it? We're going to graph it, but who has a guess of it? You could win if you just are the only guess. Well, that's the z-score. That's the z-score here. The z-score is equal to this. So that is the z-score. And then the p-value is the probability of the greater than that z-score. Is it? Well, that's the guess right now. So, Nikki, if no one else guesses, you won. Nikki, you get 200 points just for guessing first. Make sure to email me just for guessing first. So we'll see. Who's 100 points Tyler for guessing second. See if anyone can beat Brian's guess. Let me think. Oh no, you might have a really good guess there. Someone could cheat and go find it online. Okay, I'm thinking about it. Okay, I got a good guess. I think Nikki not only got the first guess, but her guess is very close to the right answer. Wait, let me think. Why did my brain break? Okay, good. Okay, wait a minute. Okay, I've got a revised guess. It's still a good guess, Nikki. But my drawing is so hard to see. Like, here's the way to tell that it's going to be much smaller. Above here is 16%. And above here is 2.5. Does anyone want to take one last guess right now before we show the answer? So it has to be between those two numbers. It has to be between those two. Because above a z-score of 1 is 16% due to the 68-95 rule. And then outside of 2 is that. So, and I know... Okay, I got a good guess. I'm guessing... Remember, all p-values need to be between 0 and 1. Wait. All p-values are between 0 and 1. Oh, you're guessing the percentage. But also the percentage, if we turn it to a percentage, would be between 2.5 and 16% if you do it as a percentage. So you can do it, but just make sure to put the percentage right there. So it has to be between these two numbers, between these two right here. It has to be between those. Oh, no worries. So it might be hard to tell, but I'm guessing about 0.064. Now, the thing is we don't even need to guess it because we go to Mr. David M. Lane and we make our graphic and we go above it. And there it is. And it was that right there. So it's 0.065. And this was our guess right here. I said 4, and we were off by just the tiniest of bits. But it was between these two numbers. Now, notice, I want to point this out. Does my graphic kind of look like their graphic? If you look at my graphic compared to theirs, now it's not perfect, but does my graphic kind of look like their graphic? Like if you look at our two graphics. So that's what you want to see, is you want to kind of do a quick drawing of it, a quick sketch, and you should get the same shaded area as they get. It's not perfect, but it's in the same spot at a z-score of 1.5, and then we shade above it. If you can do these kinds of drawings, then you'll make sure you get the right picture. So if you really want to practice this, make sure, Nikki, excellent job, great guesses. Nikki earns the 500 points right there for playing the Guess the P-Value game. So we've got all the answers right now, I believe, because we know determine the test being used. The null has the equal sign. We're going to test greater than. The test statistic right here was the t statistic we found. There's the t statistic. Oh, wait, we got to delete some. That's the t statistic right there. What was your z-score, Tyler? You should have gotten a z-score of like 3.8. Did you get like 3.8 or something? A z of like 3.8, 3.7? Maybe like 3.6? High 3 something. I think for that. Maybe like 3 point something. 3.5. If that was your z-score like 3.5, then you probably did it correct. If your z-score is like 3.5. Because that's the p-value you would get for that. And here's the p-value. Would you recommend the company use the advertising? So they're not going to reject the null. And they're good. Yeah. What was your z-score, Tyler? High 3 z-score. Yep. Then that is accurate. That p-value is about what you should be getting. And you'll reject the null. You'll reject the null. If you're doing the same exact question, you will reject the null. Yes, because the null hypothesis is rejected, there is evidence, but I'm not going to reject the null. I don't have a p-value below the 0.05 alpha. So mine is going to be no, there is insufficient evidence. No, thus there is insufficient evidence that more than, let me see what the difference here is. No, because the null hypothesis is not rejected. There we go. So the only two answers here are yes, because the null hypothesis is rejected, there is evidence, or no, there is not evidence. And we should say, never, my Pearson, never today. You can't trick us. We got this. Could I have guessed this? Woohoo! Yay, we guessed it. And we see at the end that we got it. So, who has another question? We've done a lot of these today. We've done a good bit. We've got a lot of them done. Null has the equal sign. The null has the equal sign. This right here is percentages, so it's proportions. This is proportions. Wait, 20% of cars. Cool. It's proportions. We field test a new soft drink to see if people like it. That's the proportion of people who like a soft drink. These can only be p or mu, depending on if it's proportions or means. Now we have to know the value being... oh, wait, we have to look at the sign. In 1950s, only about this. Has it changed? So that's not equal to. The manufacturer hopes that the redesign has solved the problem. So 20% of cars need transmission work. They want to decrease because they want the proportion of cars with transmission work errors to go down. We field test a new soft drink, planning to market it only if over 60%. So that's what they're looking for evidence for. They want over 60%. Did we do it? Not today, my Pearson. Not today. So please notice how, once again, we were able to solve all this problem here by identifying some key features of it. Is that the null always has the equal sign. That knowledge makes this part very easy. You don't even, use your knowledge before looking at the answers. Be like, well, the null has the equal sign, so cool. And then whatever I pick here will also be picked here. So whatever you pick in this spot has to go here. So if you were to pick mu, which is a possibility, you'd also pick mu there. But if you pick P, which is the right answer, you will pick P here. The last part of this right here, the sign for the alternative, is based on what they're asking. They're asking, has it changed? So that would be not the same. This one wants to know, have they fixed the problem? So they'd want the proportion of things with transmission errors to go down. The true proportion of cars with transmission errors is going down. This one wants to know the true proportion of people, which is P, because we're talking about do they like the soda or not like the soda. And we want to market it if over 80%, 60% like it. So we want to know that the true proportion has increased or is higher than the hypothesized value. And let's see if there's any other questions that we would talk about. That's one we just did. This one's very, very similar. We'll see if anyone has any other ones that they're stuck on. Do we not? We did the twin one, right? So maybe that one's on here twice because we did the twin one. This one, very, very similar to the ones we've been doing. Do we have some multiple choice? Which of the following is appropriate null? Has the equal sign. Which of these? In a criminal jury, not guilty is the what? Oh, wait. Finding someone not guilty would mean what? That would mean we fail to reject the null. So they put the bad except word on there. Don't do that. And last but not least, the probability of seeing something or something more extreme given the null is true. Who knows what this is? Don't look at the answers. Who knows? 100 points. Who knows what the answer is? The probability of seeing something as extreme or more extreme given that the null is true is a what? The probability of our results more extreme happened by random chance variation given that the null is true is a 100 points. Who knows? I'll probably head off here. Good work today. Or if you have questions, feel free to ask. I'm going to see why my music is not playing. No one knows. I've stumped everybody. The probability of our results or results more extreme happening by random chance variation is the p-value. So once you see the definition, it should be like, oh, that's p-value. But that's got it. We've done a lot of the problems now. So we've done the vast majority, and we've pretty much covered all the different types of problems on here. So I feel pretty good about this. If you are stuck on a problem, please email me. Remember, doing the quizzes, doing the homework, stay on it and keep working it. And if you have questions when you're stuck, email me. But that's going to be it. Who's here? Is anybody here to say bye to? Is anyone watching to say bye to? You're welcome, Elizabeth and everybody. We'll say bye. Go back to our screen right here. We'll go back to the screen. Does the music play on this screen? Is it my Go XLR that's not playing the music today? Can I play my music on this? Let me try the music. Oh. It's like the Go XLR is not playing my music. Oh my God, I should load it up. Oh, good to see you here, Hannah. Are you doing all right, Hannah? Can't hear Wah Man. Did you have any last questions, Hannah? As we finish up. I wonder why. If you have any, feel free to ask. We've gone through most of the questions here. You're good. Awesome. Rewind the video. Check it out. Email me if you're stuck. You guys got it. I'm going to head off here. Good seeing everybody. Bye for now. See you tomorrow morning or maybe later. Who knows? Bye, everybody. Bye.